Okay, this is needle code number 6, ZigZag Conversion. The string whatever is written in zigzag pattern on a given number of rows like this. You may want to display this pattern in a fixed font for better legibility. So we have PAL, then go up, then go down, go up, go down, go up, and go down. And the output should be PAHN, then APLSIIG, YIR. This is our output. And we have then read line by line. Write the code that will take a string and make this conversion given a number of rows. Example, number of rows equals 3. This is our output. Number of rows equal 4. So equal 4, then go down, then go up, go down, go up, go down. Output should be PIN, ALSIG, YAHR, PI. This is our output. So this problem looks like we can do exactly what we go before. We can read the string, go down. Once we meet the bottom, we go up. After like a number of rows, we go down again. After 4, we go up again. After 4, we go down. And while we traversal, we can fill in a 2D matrix. Then we go through that 2D matrix. Whenever that position have value, we append it to a string buffer. Finally, we get an answer. One observation is this space is actually not necessary. We can collapse this column and this column into one, so we can have a array. They collapse into one column, and this position is actually neutral. You don't know this is go down or go up. You can assign to this column or this column. It doesn't matter. So let's assign the to the go up column. That will make our algorithm easier. So let's put P to the go up column, and I again. This is the neutral column that's assigned to go down column, and this I neutral column that's assigned to go up column, then go down. As you can see, if we do those rearrangement, we have exactly the same output: PIN, ALSIG, ALSIG, YAHR, YHR, PI. So the same. And we need to go down. In this case, the number of rows equal 4. We need to go down 3. Then we go up 3. Then we go down 3. Then go up 3. Then go down, whatever, left. So every number of rows minus 1, we change the direction. When we go down, we start from row 0. When we go up, we start from the last row. So this should be pretty straightforward if we use a 2D array and fill it. So this is the code. If we have an empty string, let's return empty. If we only have 1 row, we don't need to do the rearrangement. And otherwise, we create an array. The array should be big enough, the number of rows. So it's the rows should be equal to the number of rows. How about the column? Each column we only hold number of rows minus 1 characters. So totally we need S over number of columns minus 1. This is total number of rows, and whatever left we need an actual column. So this is the size of our 2D array. When the number of rows is big, we actually this -1 doesn't matter anymore. So it's roughly proportional to the strength length of the string. And at the beginning, we go down, and our counter is 1, and we start row and column 0. Then we iterate through the string. We fill the current row and column with the current character. If we go down, we increase the row, otherwise we decrease the row. For the counter, in the normal situations, we not change the direction. We just increase the counter and doing nothing else. Otherwise, we just count enough to change direction. At that time, if we are down, the next row should start from the last row. Otherwise, the next row should start from 0. And we change the direction. We put the counter back, and we increase the column. We start to process this column, then this column, then this column, then this column. So finally, we should have the answer. Once we have that array, we initialize a string buffer. If that value is not a default, we append. Finally, we return the string buffer, and that is the answer. Okay.